Good afternoon. No, it's still good morning, isn't it? Yes. Good morning, everybody. And this is topic, as I just said, is critical minerals, critical risks, securing supply chains, and this is a critical discussion. Uh, I don't think 3 years ago or 4 years ago we would be talking about this, but it's obviously front and center. I was just talking about there have already been a couple of orders from President Trump relating to emergencies around critical minerals. It's very much under discussion. It's very much caught up in the trade debates and, of course, in terms of the tensions between the United States and China. So we have a great panel here that brings very important and diverse points of view. Frank Fannon was the Assistant Secretary of State in charge of the Energy Bureau and really put the spotlight on minerals as an issue, and he now heads Fannon International Advisory. Vandita Pant is the CFO of BHP, a great mining company, and of course brings the industry and global market point of view. And before that, she was in charge of, in fact, marketing, chief client officer. Kei Onishi is from Yamaha, which is a motor and mobility company. We all know their names. Their motors are everywhere, and he'll bring the viewpoint of an industrial consumer. And Nick Myers is from Phoenix Tailings, and will bring the viewpoint of technology as solutions to it. So I wanted to begin with the panel by just asking each of them, why are we discussing critical minerals? Why is it so critical? And we'll just go down the line to open up the discussions. Why don't we start with Vandita?
Yeah, thanks, Dan. We're talking critical minerals because the world, what it's going to do, it needs the resources at the scale that we've never had. Be it continuing development of the world, but now amplified by energy transition and energy security, and now increasingly amplified by need for digitalization. So all this means that the commodities and the resources, critical minerals and strategic minerals we are talking about, have never been needed more. And the challenge to get them online is really for us to embrace. To give you a short stat on that, copper, which is ubiquitous, be it in white goods, be it in EVs, be it in power grid, be it in data centers, needs to grow from a demand perspective, 70% to 2050. Just the new application of copper in AI and data centers goes from almost nothing 4 or 5 years back to 3 million tons of copper needed just for that.
So Vandita, we're going to come back then and talk about what are the challenges to getting that done. Kei, why are we talking about critical minerals from your point of view?
Yeah, from automotive industry's perspective, talking about critical minerals is really critical for the sustainable growth in the auto industry in the age of electrification. Let's take an example of existing ICE engine cars. It doesn't require lithium, cobalt, but we primarily use aluminum or steel. But now, in the age of electrification, lots of rare earth critical minerals demand sparked. So do we have enough demand? As Vandita mentioned, we don't have enough supply. So that's why we need to talk about critical minerals to support the electrification of the mobility and logistics industries.
So, and what do you use them for?
So primarily, batteries. That's the one, and still we see tons of hybrid cars as well. It still has the catalytic converters that consume tons of PGM, platinum group metals as well. So for electrification, we want to have a little bit lightweight structure. To achieve that, we would probably need a little bit more magnesium as well. So and also for the coating, maybe chromium as well, or titanium. There are lots of the critical minerals consumed for the electrification.
Right, thank you. So Nick, from the viewpoint of I guess if you're 7 years old, you're not a startup anymore, but as a graduated startup, a technology company, what's your perspective on why we're talking about critical minerals?
Oh, thank you, Dan. Yeah, absolutely. Great question. I would definitely echo the points already made. But ultimately, I think it boils down to the fact that we need the metal for everything that we rely on, whether it's wind turbines, electric vehicles, medical devices, or defense systems. We need it. And let's be honest, none of us have a freaking clue about how we're going to get it. China dominates this market. In rare earth metals, they have 97% of the metal output in the world. 97. 2% in Russia, 1% in Myanmar. How on earth is the United States going to compete at all if there's an economic warfare?
So we'll come back and you'll answer that question,
Please.
right? Okay, good. Frank, from a geopolitical point of view, why are we talking about critical minerals?
Yeah, just to underscore the point, I mean, we talked about the concept of an energy transition a few years ago, and critical minerals are needed for that. I think that's small ball. What we're talking about is really a forward on economic transformation of the modern economy, which requires, these are the chief inputs to AI, to electrification, to mobility solutions, to modern defense system platforms. We're talking about them because China dominates them and has used their dominant position to assert leverage over the United States and others. They have them and we don't.
So now that we know why we're talking about it, Frank, when you were in the State Department and then in the years since, how have you seen this issue evolve from a political point of view? And where are we, and where do you think we are with it today, with the administration?
Yeah, I think it's important. We did start talking about this issue set in the first Trump administration. In 2018, President Trump issued the first critical minerals list anywhere. So I would say that has certainly continued to ramp up attention. The issues around critical minerals has only increased. Much of that was related to China's escalatory actions in that domain, and it's certainly not just in the context of banning exports of different things and reduced exports, but also their ability, which they've used frequently, to effectively dump material onto the market to undermine the economic investment thesis for Western supply chains. So they're on both sides of the trade here, really exerting an outsized degree of control. And this is, as you've written about, Dan, the commanding heights. This is the commanding heights of our position in the world, our ability to drive economic growth and security.
Right. It's interesting. Critical minerals, you try and track it down, and you can take it back to World War I and talked about war materials. And then after World War II, it was an issue. And then kind of, I think, in around 2008, government started publishing these lists. But Vandita, from your point of view, how has the thinking changed within a global mining company about these issues?
So, Dan, what is important is that we are very deliberate about choice of commodities. And if we look at some of these resources and the critical minerals we are talking about, they are based on mega trends. But what is the problem and the solution right now? I want to get to that. From a biggest mining company in the world by market value, the way we think about this is an absolute opportunity to fulfill this demand. Over next 10 years, just for copper, which is one of the critical minerals we are talking about, we have a gap of 10 million tons of incremental copper supply needed, just for next 10 years. And by 2050, copper demand is expected to grow by 70%. Now, while the underpinning of the demand is so strong and so critical, it's ubiquitous and needed, on the other hand, the supply is becoming quite constrained. In last couple of decades, we have hardly had a handful of large discoveries.
Why?
Because if I can say, the quick wins have been had. The top 200 meters of Earth's crust has been mined and we know about it. Now, as the mines deplete, both in grade and in resources, they become harder, they become deeper. The technical expertise needed to bring this supply to ground is more advanced. And, of course, the projects take a long time to come to fruition. All of this supply gap, if you will, means that we need to have lots of things happening together. So a mining company or the industry needs scale, these are multi-billion-dollar projects now, need strong balance sheet because financing is not for small dollars. We need huge technical capability because projects are becoming difficult and some of the projects never come to fruition. And on top of all this, we need right kind of standards so that sustainably one can do mining and have license to operate in those communities.
Nick, you wanted to come in on this?
Yeah, absolutely. So that's a really great point. And I would push that I think if we do the same thing we've done for the past 200 years by building more mining projects, it doesn't actually get us to the point we need. We need to invest in the technology to upgrade the ore in a better fashion. That's the problem with critical minerals that's different than, say, iron ore production. You need the chemical processing to take an ore into the final metallic form. The U.S. has what, two copper smelters? And China has how many, 52?
I think 52.
52, right? What are we talking about as competitive-wise, right? We have to really invest in that refining capability so that the new BHP deposits can be capitalized on better. And it's about working on a collaborative supply chain here that's not just digging new assets, but it's taking the assets that we already have and maximizing the value of those by investing in the middle part of that supply chain that no one really has put the capital in before.
Right. So we're going to come back to that in a minute. Just wanted to, Vandita, just to finish on that, our numbers at S&P is that it takes 16 years to open a major new mine. In the United States, 29 years. Why does it take so long?
Yeah, so that's a very good question. Like Nick just mentioned, given we have such a focus on domestic mining, and I must say, in the US, that has been bipartisan stance. Momentum has been building. The both to see the criticality of mining, but also a recognition that the mining processes are too complex, the permitting processes are too complex. So as you said, it takes 29 years in the US, but that is improving. We have seen the current focus of the administration in taking out duplication, making it more transparent, and going with the permitting reform. But if I were to look at across the nations, I think this is one of the key levers for nations to attract investment, to unlock their resources for economic development, which is needed in the countries. And a very good example, you may be surprised here, is Argentina. Just yesterday, we announced that our joint venture we entered into earlier this year of copper mining along with Lundin Mining, that we have announced the results of the resources, and that is the largest greenfield copper resource in the world discovered in last 30 years. But the government there, Dan, is really very focused on attracting investment and unlocking resources like this through better permitting reforms, through fiscal package uncertainty, and that's super.
So take that as an example. Was that that's a pretty significant discovery? Was it just somebody stumbled over it? Was it the technology improved, or is it just nobody had looked? How come that huge deposit's sitting there and no one knew about it?
No, it's not about no one knew about it, but as you know very well, that region is very copper rich. We have Chile has been home for BHP for a very long time, and we run the largest copper mine in Chile, in the Andes. So that region is very rich, but of course the drilling and the exploration is needed, as you know, for a very long time to do, and that has uncovered this, which we think can be among the top 10 copper assets in the world.
And how long will it take to bring that?
So this is where the permitting, along with when you see the first production, is so interlinked. So permitting processes take a long time, as we are discussing. A regular project will take from idea, FID, to another 5-6 years, and the payback is 6-7 years. However, that asset then is of value for 30, 40, 50 years. So we are talking about long-term investment, which means the faster we can get to the front end of permitting, the better it is to unlock those resources. And secondly, the fiscal settings and certainty become so critical because your risk and return is multi-decade investment of multi-billions dollars.
Right. So Kei, let me turn to you now and ask Yamaha motorcycles, motors of all kind. You had a wake-up call about this issue earlier than many others. I think, was it 2012? Tell us what happened.
Yeah, so around 2010 to 2011-12, China started restricting the export of rare metal elements.
And was it? And they were doing that to punish Japan for something.
Yes, yeah, to punish Japan. Yes, and like us currently, what's happening within China and U.S. I think we can learn a lot from that. What happened and how Japan reacted from the 2010. What happened in 2010? So that was absolutely a wake-up call. So as a system, so auto industry, especially OEMs, we are like a system integrator. We source lots of materials and components from tier 1, tier 2, tier 3 suppliers, and we have been super focusing on optimization, assuming that the current geopolitical situation, supply chain, and also supply will not change. And we optimized our supply chain based on the three criteria: quality, cost, and time, lead time. But 2010 was a serious wake-up call. Okay, these three is not enough. We need to also look at the resiliency. Back then, we were using different terms like a business contingency plan or sustainability, those words. So we got the first criteria to make a decision. So and we started working with the tier 1, tier 2, tier 3 suppliers to visualize where the rare earths came to our supply chain first. Mapping, visualizing our supply chain is the first. But still, it's ongoing. It's never-ending, effort. Always, every year, supply chain changes, so you need to keep updating the map. That's one. Two, identifying the critical single point of failure. Where is it? And can we solve the challenge with our effort or partnerships or leveraging the government industry partnership? What we realized is Yamaha is so tiny. We cannot have any control power or buying power to influence on the entire supply chain.
I mean, you're not that tiny. I mean, you do have a lot
Yeah,
of motorcycles.
still. There are multiple, actions you could potentially take. One, finding an alternative source, non-China rare earth. That was not really there. Two, vertical integration, which is currently Tesla or Toyota or lots of European OEMs is taking, owning the refining capabilities or investing into mine, so vertical integration. Third, finding substitute. After the 2010, Toyota or Hitachi Metal successfully developed the rare earth-free magnets for especially hybrid. That was great. Fourth, recycling or circularity, but it requires technological advancement and breakthrough. Fifth, I think that was a huge for Japan. It was the formation of JOGMEC. Japanese government worked intensively with industry to strategically pile up the rare earth reserve as a country, and also financing
To build reserves within the country.
and also access to the source as well. Financing the development of the mines or supply as well. I think that was huge for a company like us. We are not small, but not big enough to influence the industry. So partnership is absolutely critical as a core of our strategy since then.
Right. And how is it? How do you feel about where you are today?
So after what happened, China started, also exporting rare earth again, and so we go like, okay, supply is there, so maybe we can go back to the operation what we had in the past. So sort of like we started losing the sense of urgency, and now it happened again. So
It happened again because of why? What?
because of like two things, U.S. China, the geopolitical tension, like as Japan had with China in the past. One, but two, the second point, this is a fundamental change from the 10 years ago, 15 years ago, which is electrification. Right. Demand for rare earth critical minerals skyrocketed, and those critical minerals are highly concentrated, especially the refining capability, like as Nick mentioned, over 90% is in China. So now, like customers wants to buy more two-wheelers or cars. India is an important market, and you should take a look. Last year, India sold over 1.1 million motorcycles, and the penetration is 5. CAGR for the last 3 years is 87%. It's huge. So do we have enough supply?
Well,
We need to work together.
okay.
Yeah.
Well, that gets us to Nick, because Nick is trying to change the supply equation in a very dramatic way. Tell us about what you're doing, but tell us it came out of, like many miraculous things, came out of a lab at MIT. Is that right?
Give or take.
Okay.
Happy to share. So I met my co-founder, who's a PhD from Boston University, undergrad MIT. I've been working on technology for the past like 20 years before that. But I met him at a Bible study 7 years ago, or 8 years ago now, I guess. And we started talking about the biggest problems in the world, as one does, right, late at night.
At a Bible study.
At a Bible study,
You
of course.
should. Yeah.
One of them being actually how we get raw material to the final metal form that we need for all these amazing technologies. And we saw that in China, they do this today. What we were focusing on then was less the geopolitical issue, which has come up more now, but actually more on the human rights issues, right? They have 2,000 tons of waste for every ton of metal, and it's a lot of HF gas emissions, just really, really bad stuff. And there's a lot of worker safety problems that happen in this ecosystem. I'll let you all Google what that is. It's not good. And we said, look, we don't see anyone trying to solve this problem.
So, by the way, I mean, sometimes when people talk about clean energy, they forget that all that stuff is not clean.
Correct. Yeah, so I think the biggest thing, actually, the onshoring of rare earth metal processing or critical metals processing here to the U.S. is probably the best thing we can do from a sustainability standpoint and a clean tech standpoint, environmental standpoint, simply because the U.S. has such better standards for how we process things. Like we don't discharge HF gas emissions here.
Right. So you guys were talking about this at the Bible study.
Yeah.
Decided, okay, and then what happened?
And we said, all right, well, no one's solving it, so let's go and do it. So we pooled together our entire life savings, which was $7,000. You can laugh at it, it's fine. And we built the first prototype in the backyard of Cambridge, Massachusetts. So we've worked extensively with them.
So you saw a technology path.
We saw a technology path. The first tech we used was not the right one. We iterated and built it up. The way our growth path is different than what traditional technologies are. And this is the message I would give to everyone who's looking at investing in technology and looking at the sector as a whole. It's not about spin-outs of universities anymore with these critical metals companies, right? If you do that, they license to a big corporate, and then they struggle a fair bit to scale up.
No, Vendetta doesn't like that, but go ahead.
I will think.
No, I would challenge that. For example, for BHP, we are not only dependent and looking at, as the largest copper producer in the world, how we can get more out of earth, which is needed. You can't refine what you don't have. So that is needed. But equally, we have our corporate venture capital arm, which scours the world for new ideas. And in fact, 75% of our corporate venture arm investment is right here in the US.
So afterwards, you two can get together and
Yes.
Yes.
get out.
I've met the
But
BHP.
now that I've interrupted your train of thought, let's pick it up again.
No, it's okay. So that's actually my point. So BHP is one of the very few mining companies in the world that has a proper CVC, corporate venture capital. And they are one of the best. They are very good. Most mining companies don't have that capability. But Silicon Valley technology approach is really what we're seeing as a growth path here, which is that style of investment. It's a little different than the spin-outs. So we built that way, right? We built the first prototype in the backyard. We now have 34 patents and trade secrets around our company. We've raised a little over $90 million in total capital raised so far. We just closed $76 million last week. We're very excited about it to scale up.
That's why you could come here this week.
That's why I'm allowed out of the office. Yeah, it's great.
Yes.
It's good. Yamaha came on board. We're very honored to have them, as well as In-Q-Tel, Envisioning Partners, and Sumitomo, some of our biggest backers. But we scaled up since that backyard. We run one of the only rare earth metal processing facilities that are outside of China today. So we ship metal today. We have a $200 million signed contract where we ship metal to customers producing magnets for the electric vehicle sector today. We've built that in Boston, Massachusetts. And we currently operate sustainably in, Burlington, Massachusetts, so 20 minutes outside of Boston, but close enough. We produce metal consistently there, 24/7 operation, and we're scaling up to our new facility in Exeter, New Hampshire.
And so you're taking rare earths, so they're being mined somewhere.
Correct. Yeah, so we process both recycled and mined material today. We do what's called the refining stage. So after you dig a hole in the ground for rare earths, you produce a concentrate. Traditionally, that's all been shipped to China to process into the final metal. The way we intervened in the market, we saw that gap. We started building our own refining capabilities, avoiding emissions, doing it at lower cost, and making sure we can do it here in the United States cost competitively. And we buy material from normal mining companies and recyclers and process that to the final metal. Long term, we look to leverage our refining capabilities to process material from tailings, which is a waste product in mining. And we have our own tailings site in upstate New York that we work off, which is an old iron ore tailings site. And we can recover rare earths from that. But that's scaling up long term. Right now, the key gap in the world is specifically the refining of rare earth concentrates to the final metal and metal alloys. And that's what we focused in on today. And we're scaling up pretty aggressively. We're one of the only producers. And with more folks like ourselves, we'll be able to actually...
And this is an entirely different path than the traditional.
Correct.
Right.
The traditional path for Chinese processing of rare earth metals produces 2,000 tons of waste for every ton of metal. And it's fluorine gas is the major discharge. You really can't operate that anywhere in the United States under any circumstances. You can put as much insulation around as you want. It's never going to really operate at scale. So we took an entirely different chemical approach, and that's what we built in the backyard. And it's fully permitted to operate in Boston, Massachusetts, which has way stronger environmental.
So this didn't then come out of a lab at MIT. This came out of...
Correct.
Divine intervention at a Bible study.
Right.
Yeah, so we built it up in the backyard. We do work very heavily with MIT. So MIT actually, in the vein of the Silicon Valley, the corporate venture capital arms, they actually work with BHP quite extensively. They have startup groups. And this is where we leverage. So it's not out of a proper lab at MIT, right? We don't have like joint ownership of IP and stuff like that. But we work with the startup groups called Venture Mentoring Service and the Industrial Liaison Program to leverage the MIT network available to alumni and founders that are approached in the ecosystem. And they've been extremely supportive of us and very, very, very helpful. We got some of our first grant funding in conjunction.
And do you don't produce then 2,000 tons of waste? Do you produce
No.
any waste?
No, it's a zero waste, zero emissions process designed to compete cost competitively with China while operating here in the United States.
Are people beating the path to your door?
It's going well. We sold out our entire, 3 years of production. Now we're looking to expand more.
And where do you get the raw material?
U.S., Canada, and Australia primarily.
So
Right.
there's no shortage of the raw material.
There's some challenges with some of the more rare materials like terbium or yttrium are a bit trickier. But for the majority of rare earth metals or rare earth concentrates, the U.S. actually is one of the largest producers in the world outside of China. And China only controls about 50% of the global mining of rare earth metals.
So let me ask you and Frank the question. Is it correct that there is a panic about rare earths right now?
I would say so. It's a bit of a challenge, right? Remember that 97% of the rare earth metal supply, not the rare earth concentrate, but the final metal, comes from China. And they shut off exports of this, or they restricted exports a few weeks ago. So that means that in 6 months, no car company in the world is going to have access to raw material.
I heard one car company say in a week and a half. So,
Yeah.
Yeah, I would just like to go back to the to this 2010 issue. Just for everyone's awareness, the conflict in 2010 was over a maritime fishing dispute where Chinese vessels were illegally fishing in Japanese waters. And Japan repeatedly said stop doing it and finally took action. That was what what the response by the Chinese was to ban the export. Overnight, the prices went up 350%. And I agree that it was a wake-up call, but I would suggest that we hit the snooze button.
well, that's sort of what Kei said, that
Yeah.
afterwards people got more comfortable again.
Because the response, particularly of the U.S., Europe, and Japan, was to do what has always been done, file an action in the WTO. And it took about 3 years for that case to be litigated. And in that intervening 3-year period, China went from banning rare earths to dumping them on the market and helped facilitate the one rare earth company in the United States to go Chapter 11. So what the wake-up call really is you can't go into business like that any longer. We can't abide by a certain set of traditional rules where the dominant player ignores them. So we have to chart a new course, and I think that's what we're doing. In terms of the rare earths, the other thing that's important to note, it's not a big market. It's tiny. What is it? Globally, $14 billion value. It's nothing. But and you only need a little bit of rare earths in a product. But if you don't have them, it doesn't work. So like the F-35 landing gear uses rare earths. Well, you need to be able to land the plane. So, it's one of these questions, and I think that's a whole nother question of valuation as we go forward.
Well, I was struck, and you bring that up, that in December when the Chinese started to put controls on, they invoked something that the U.S. had been invoking on its trade restrictions on chips to China, dual use. That is, that it was being used by the military as well. So it's very deliberately aimed at.
Yeah, absolutely. They're going after the defense platforms. At the same time, they're mobilizing around Taiwan.
Yeah. So, Frank, we're in this turbulent sea of tariffs and trade war.
I've heard about it.
Yeah. So, what's been the impact, and how is this playing out within that context?
Yeah, I think as a general matter, most of these critical minerals were exempt, but of course there's knock-on effects to some of these other industries, and I think you're starting to see various negotiations are very much in flow right now, and I think the Treasury Secretary spoke to that. Some 70 countries are in Washington frequently to cut a deal, whatever that may look like. What I'm particularly interested in, less so are the broad tariffs and Liberation Day kind of announcements. I'm particularly interested in late last month, the administration issued an executive order directing a 232 investigation into critical minerals, particularly into the processing dimension. And that's going right to the heart of this, of really China's extraordinary control of processing and manufacturing and finishing. And so there's also issued in that executive order, there's going to be an expedite. Usually these things take about 270 days. There's going to be an initial report in July. Like they're moving this very fast. So I think that is an appropriate targeted approach. We need to start creating understanding, and Nick spoke about the emissions and some of the other costs that are these externalities that are not evident. They would be evident if they were being produced in a Western U.S. supply chain. So we need to expose that and demonstrate what is the real cost structure of some of these companies. Because I think once we do that, we can then understand how they produce it, how it's another form of dumping, and then we can impose some type of countermeasures that are appropriate. Which again, this is about investment, and we need to create the conditions for these industries to be more readily investable.
Vandita, has the world gotten more complicated for you all?
The world is complex in terms of uncertainty and volatility, no doubt about it. I think the first order impacts for a company like us are minimal. However, it's not about first order impacts. As we have been discussing, what we need to work through is given where the policy will land, both trade policies and realignment of trade, the impacts on economic growth, if any, are there views around a recession and inflation that comes through, and what are the structural things? But if I were to sort of step back from the noise of here and now, on the topic of the day that we are talking about, nothing changes on that. The mega trends that the world needs around development, around digitalization, around energy security and energy transitions are very much needed. Just from here to next 10 years, the reality is 10 million tons of more copper is needed, which is $250 billion of investment.
Well, as you know, some people refer to copper as Dr. Copper because copper diagnoses whether we're in an economic slowdown or a recession. What is Dr. Copper saying to you?
Well, Dr. Copper has been resilient. And not only copper, but commodity set, in spite of the volatility we have had, have held up very well. Having said that, of course, the copper being the bellwether of economic growth, and given the financialization of copper, does mean that there is an overhang of the prices and the sentiment which can come through in the prices, which is what we are seeing. However, fundamental demand for copper hasn't shifted really materially. What is important, of course, is to see how do we make sure that the structural gap which is going to emerge by the end of this decade in copper and which almost doesn't close in spite of very aggressive recycling assumptions that we are able to use the kind of resources already had, we have a huge gap to fulfill.
Well, I know we did a copper study 3 years ago that BHP participated in, and we said to meet the kind of 2050 goals of a Biden administration or the EU, copper production would have to double by about the middle of the 2030s. And when we were talking and we were looking at the numbers, we actually see that the energy transition demand is ahead of where we thought it would be 3 years ago, plus all these new, with data centers and so forth, and all the extra transmission. So that suggests that the growth of copper is going to be critical to meeting data centers and all the other things that people want to do.
And this is not a small gap to fill.
Right.
In dollar terms, we are talking about $250 billion investment for next decade. Okay. And our run rate as an industry on copper investment has been around $150 billion for last 10 years.
Well, the inevitable question, I suppose it runs through everything. Does AI make a difference in terms of exploration?
I think AI is both a big driver of demand, a big unlock of resource. It's a big driver of demand from nothing to becoming 3 million tons of demand driver for copper. Just to put things in perspective, 3 million tons of copper is 3 times the largest copper mine in the world, which we run in Chile, in Atacama Desert. That's the demand factor, which is very exciting. In fact, if there is no copper, there is no AI, there's no data centers, there's no cooling, there's no transmission, everything that is needed. In terms of unlocking resources, very exciting, Dan. For example, we are already using machine learning and big data sets from a multi-science perspective to look at more targeted way in exploration. And that has been very useful in both in Australia and, in fact, for a small deposit here in the US as well. Equally, the technology unlock on AI for higher recovery, lower use of water for production, throughput mechanisms is a big unlock in mining. And for us, that's been the reason that for a long time, we're digitizing all our 100 years of data, because once you have that, then AI unlock for the mining is needed. For a company like us, we need to use every tool in the toolkit, be it our organic big resources. We have the world's largest copper resource in the world. To unlock that supply, use technology fully in existing terms, use AI, use new technologies which are not even within BHP. This is not going to get done by one company or one industry. This will be a partnership across mining with the investors, with the governments as well.
So I want to ask a question about investors' view and of Frank, but we're speaking about technology, and I need to ask somebody from Milken to help me. I've managed to turn off the iPad for questions. So is there anybody who can reset this in case they're... So on investors, there was a lot of ESG. I remember one big investor in France saying that in Europe that it was hard for him to invest not only in oil and gas but mining because there was ESG considerations. Thank you. Oh, there are lots of questions. Okay, thank you. But just maybe go to ask you and then Frank just what you see is investor engagement. And of course, you have a different point of view, Nick, because you need to raise money. But
yeah, so I would say just 2-3 things to that, Dan. What a great opportunity. If the thematic for an investor was just economic development, as people, population grows, standards of living higher, copper being really critical, or be it the future-facing mega trend of taking exposure to AI, copper and mining is a very good central hold in the portfolio. The second thing is, as I was mentioning earlier, we have projects that we put billions in, and then the cash flow comes in over decades, multi-decades. For patient money, the returns here today and value tomorrow is a very good match of the liabilities and assets for mining things. And I would say from a ESG perspective, sustainably done, mining is the core enabler or everything that the world will need as well. Of course, what that does mean is that the scale of companies, the strong balance sheet element, technical capability have to be the moats and have to be the way investment can be done, because these are the things which enable through the cycle resilience. You need strong balance sheets to be able to not just weather the storm, but be able to continue to invest in the businesses that are needed.
Do you find institutional investors are more focused and want to learn more about mining?
For sure. I think not just investors, but the governments.
Yeah.
I think the criticality of things like copper and mining is now very much center of the table. And that is exactly right, because as I said, we haven't had this kind of a need for resources ever. And the scale needed to ramp that up
very important
is
point.
very important.
Right. Frank, what do you see about investors?
Yeah, I mean, I think it's as a general matter, there was an aversion to mining. The ESG component is one, but also the risk profile. A lot of the new developing areas are outside of the OECD, and there's a certain degree of perceived or actual risk, whether that's political risk or reputational risk, what have you. But I think that's changing. It's changing for a few different reasons. First, I think, as we've been talking about, the criticality of critical minerals is new, and the evolving nature of the economy and the growth trends. But also, you've got this policy tailwind pushing some of the adoption and accelerating that demand curve a little bit. Similarly, you have the geopolitical headwinds in the context of the dominant producer. So how do you think about that? And I think for the first time, the government is seeking to take a meaningful role in affecting that market dynamic and capital formation. President Reagan famously said, if you want more of something, subsidize it, and if you want less of it, tax it. Under the Biden administration, the focus was to accelerate deployment of clean energy technology, so they subsidized it through institutions like the Inflation Reduction Act and everything else. The Trump administration is continuing on various mechanisms for subsidization in the United States, fast-tracking permitting and other things, but they're also starting to really deploy these sticks. And we talked about the tariffs, we talked about the 232 investigations. And so I think you're going to see more and more of that, which creates, I think, an enormous opportunity for investors. And lastly, I would point out, Vandita's right, some of the big mining companies are tried and true, and they, it's like a good return, steady. They tend not to be the drivers of critical minerals outside of copper, notwithstanding, which is they're the biggest. But some of these other minerals are like the nascent shale revolution, which was all developed by independent producers and entrepreneurial wildcat kind of approaches. That's kind of the critical minerals producers of today. I think they'll eventually, and we're starting to see some of that, they'll be acquired over time by the majors, just like the oil companies acquired the early hydraulic fracturing pioneers.
So, Nick, how do you find venture capital?
The venture markets in the fall were very tight, right? So I think all of my friends that run venture companies, I think 8 out of 10 of them went bankrupt in the fall. Right? And that's the reality of it, because the market was over-allocated to venture, so they pulled back, and it was very tough to raise capital. That being said, now what we're seeing is a real big push towards critical minerals. All the sustainability funds, once President Trump came into office, started approaching that. Now, I think there's a bit of a challenge, because what they're using is orders from the president and different initiatives that are coming forward from the government to, say, cherry pick on new investments, which is not necessarily the best way to approach, but they're trying to find a way to vet and understand it. I think the corporates in the world actually have a good opportunity here to really pave the way for the future. Mining does some investment into critical minerals as a whole. I think there's a couple of companies that do that. But where I do see a lot of pull is from the downstream producers. So there's downstream players like Yamaha Motors, BMW, General Motors. A lot of these companies on the downstream side have been putting money into startups and really helping them scale and leveraging their capability to de-risk the price volatility that happens there, which is ultimate scare for everyone. But also the oil producers. I think there's a lot of opportunity in the oil and gas sector to deploy into critical minerals because they understand how the infrastructure operates. Critical minerals technology is much more akin to oil processing than it is to other types of traditional mining operations. And it's a really good environment, I think, right now to be able to enter in the sector.
Right. And Kei is a venture. Basically, you're the venture arm. Is that right?
Yes.
So, are you venturing?
I think venturing enough, as you can imagine, mining or refining is very far away from, very upstream from our, where we are. And the mining industry requires completely different kinds of engineering expertise from assembly cars or assembly motorcycle or assembly robots. So the reason why we still even we had a discussion at the IC meeting, investment committee meeting within Yamaha Ventures. Should we really make investment? Do we have enough, the internal expertise to distinguish best ones from others? And the reason why we still made the investment in Phoenix Tailings is, first, we love the team and Nick. That's one, absolutely the one.
Hey, thank you, Nick. So.
Yeah.
Thank you. Appreciate you.
Yeah, so that's one. Two, my current boss, which is a chief strategy officer of Yamaha Motor, he has been working in Mitsui Corporation doing the metal trading for over 15 years. He knows the space. Third, going back to the 2010 conversation, we proudly admitted that we are not big enough to control or taking the vertically integrated approach to secure the supply. So one thing we can do is writing a little bit of small check to the startups and knowing about what's going on at the upstream and using that information to form our strategy to swim through this the chaotic situation. And also in some cases we haven't done that yet, but one option is offtake agreement to secure the supply. So I think lots of the downstream players are putting money into the venture startups to secure the supply with offtake agreement. That is a very new trend we've seen in the last 3 to 4 years. But again, still mining industry is not the industry that not so many people understand. Right. So it's still challenging to attract lots of.
So Kei, has Japan also been subjected to these controls by China, or is it only on the United States?
At this moment, we haven't seen the real impact yet, but pretty sure it will happen because China will see Japan as a sort of like strong ally with US. So Japan will be in the same bucket.
Right. Nick, there are two questions before I manage to turn this off again. One is, why is the processing so concentrated in China? And maybe also Frank might want to comment on that. And then if you are successful, will there be supply constraints in terms of resource?
Oh, great question, actually. So the reason it's primarily concentrated in China today is the waste associated with the processing. Now, I don't mean waste necessarily from a climate control standpoint and permanent regulations. Like, yes, of course, those things. But waste in this context really equates to worker safety as well as cost. And so nobody in the United States, under any state, no matter how Republican or Democrat, wants safety issues for their workers. And everyone on the downstream side, the automotive supply chain, defense supply chain, et cetera, wants to pay lower cost. So back in the 80s, this shifted away from the United States to China. And China has been strategically investing in the sector as well as subsidizing the processing capabilities to ensure that all the rocks, all the mine concentrate, all of it goes through China to process the metal. That's how they control their trade war, the trade negotiations. Now, as we scale up, if we're successful, as of right now, we do not anticipate really any supply chain issues, right? The U.S. produces 30,000 metric tons a year of rare earth concentrate, and they can ship that out to China. They've recently stopped the exports of it because of the supply chain issues, but that's currently being mined and operated here in the U.S. And right at Phoenix's large-scale operation, when we were at 4,000 metric tons of output on an annualized basis, that's roughly about 20,000 metric tons of concentrate feeding the system. So even just operating on the current U.S. producers, assuming nobody gets up and running, we have that capability. Now, that being said, there's always more and more trace materials. Rare earths are a group of 17 different elements, all with completely impronounceable names, but that are found in small different quantities, right? It's not big mass quantities, right? The highest amount you're seeing is like 1.5 weight% on some of these trace materials. So there's more and more of that we need to be able to get access to, like terbium, yttrium, scandium, and a few other ones as well. And so that's where we see more.
Can you pronounce them all?
I can.
Okay. Sounds like a song.
It's very nice. Some of my investors can't, even though they invested 7 years ago. It's always fun.
Yeah. So, Frank, do you want to add anything about?
Yeah, I think there was it was part of the time when the U.S. was happy to offshore a lot of, coinciding with WTO session by China, and this concept that the U.S. was going to maintain the IP and let's offshore manufacturing and low-skilled things to other places, whether that be in the maquiladoras in the border region of Mexico or to China. It was the thing to do at the time. It also happened to do at the same time that Deng Xiaoping famously said that the Middle East has oil and China has rare earths. It was a strategic investment that they made because they saw it. They're prescient in the future. But this is going to be a leverage point that they could assert a degree of control, and then they finally are now playing that card today.
So one may be wondering why, if Nick is focused on rare earths, why he has Tailings in the name of his company. And I want to ask Vandita and Nick about Tailings as a source of additional supply. Maybe, Vandita, do you want to explain what Tailings are and whether there is more to recover from them?
Yeah, sure. So tailings are used in the mining process, and these are the tailings, which is non-toxic waste, but it includes quite a bit of residual metals, which can be recovered
And the
done
tailings
the right way.
and the volumes can be quite large.
They can be quite large. And in fact, we were just talking about it, that in one of our sites in Australia, we've done those experiments on how to recover more and more of metals out of it, but equally how to make them less liquid so that you can get into dry tailings kind of thing. So there is a lot of technology and experiments going on around tailings. Not just that in our Chile operations, we are experimenting with 5 types of leaching technologies, and all of them, some of them are very useful because they do not have tailings as an issue. So you can also...
You can explain that word leaching, because everybody may not know what it means. It
Yeah, sure.
sounds sort of
So
ominous.
leaching is another way. There are different ways in which you can extract metals from the ore body, and leaching is a chemical way in which you can do so. And there are different ways. We were talking about technology and mining companies looking at that. We are looking at 5 pilot technologies of leaching with different footprints of usage of water, some without tailings, but some in which the byproduct doesn't get realized. So there are many considerations of these emerging ways in which to recover tailings or not to have tailings so that you can make the process even more efficient.
And so why did you put Tailings in the name of your company?
Of course.
Since you're doing rare earths.
Yes, because so tailings are actually one of the best sources in the world of critical minerals, and they're readily available. We have more tailings available here in the United States than we ever could process and mine. And in the tailings themselves, you have a very good content of the rare earths, of the other critical minerals, because simply it wasn't the material they were going after for originally. Right, in upstate New York, we have a currently signed 4 million tons of iron ore tailings with another 60 million tons under MOU right nearby, all of which has a very high amount of terbium, dysprosium, neodymium, praseodymium, and yttrium, all rare earth metals.
Well done. Well done.
Thank you, appreciate it. It comes up. And so our long-term vision here is to empower companies like BHP, Rio Tinto, Alcoa, et cetera, to be as successful mining operations as they possibly can by working with them to process the tailings, making them non-hazardous, eliminating that liability on their balance sheet, and allowing the recovery of these rare earth concentrates from that discarded secondary ore, as we like to call it. But it's a new age of mining. It's a different type of technology than you approach it. You can't use the traditional mechanical processes. You have to approach things like leaching or biological approaches or different other things to be able to upgrade it from, say, 100 ppm of terbium to the 45% weight content that you need to actually go to the final product.
And so is it the same technology you're using for rare earths that you're using for the tailings? Or
Oh, no, it's different stages. So we have, there's a numerous different types of technology that approaches it. So we have 34 patents and trade secrets around all of our processes. For the rare earths, there's extraction, separation, and metallization. Separation and metallization are both on the refining. Extraction is what you look at for the mining side. And that's what we were talking about with leaching and different things. There's variants of leaching technologies that you can put in place that don't have the emissions or discharge, et cetera, that would be a major problem if you're going after tailings. For our refining, we use separation and metallization technologies, or metallization being the best in the world because we don't have any emissions from the process and entirely clean, super low cost for the process. And we leverage a modification of technology on the separation capabilities.
Right. So, Vandita, you started off by saying the world's going to need a lot more copper. And you've also indicated it's not going to be easy to achieve that. What happens if it isn't achieved?
We don't want to be in the world in which it is not achieved because, as I was saying, copper is ubiquitous and all the things that we are doing will not get achieved if we don't. But what happens is that in case the structural gap doesn't get met, of course, the prices can fly up for the commodities like copper. So inducement price keeps going up to bring more supply in and the prices fly up. This is not the place that we need to be in, and hence to make sure that inducement prices will be higher, but we continue to increase the supply to match the demand which is needed.
So the price signals are important.
Are super critical. As I was saying, each of these projects are multi-billion dollars. The paybacks can run into 5, 7, 8 years. And the beauty, of course, is that these assets last for multi-decades. And hence, to unlock these resources is absolutely critical. And the price signals does mean that the inducement price will be higher, but we do not want the material gap between supply inducement coming to the market and demand signals, because that can cause...
Because the imbalance on the other side.
Indeed.
Do you see, are the price signals sufficient now to bring the investment that's needed?
I think the capital intensity of mining has certainly gone up very clearly. And it has gone up also because, as I was mentioning, you have to mine deeper and more complex ways, which means there is more dirt to be moved to get to the mine that you need, which means all capital is higher.
And the quality is going down. Is that generally?
So quality is not going down. So what happens is as the mines mature, the grades come down and the mines deplete. So think of it this way, that even to stand still, we need to continue to replenish the supply. And we are not standing still on demand for copper. We are actually growing copper by 2.5% per annum, very conservatively speaking, CAGRs over decades to come. And if that's the case, that divergent jaws which opens up, that's the one which is a challenge, but I think it's a fantastic opportunity to be able to do that with the right kind of collaboration by mining companies, by investors, by governments, because it is the underpinning of the world that is what we want to live in, which is data enriched, which is decarbonized, and which continues to develop as we need to continue to raise the standards of living in the world.
Right. Well, we started with a question of why is it critical to have a discussion about critical minerals and supply chains? And I think we've answered that in this. We've also answered the questions or have a sense of what the responses are, which are in terms of technology, in terms of investment, also, though, very much colored by what happens geopolitically among nations. So it's a complex picture, but I want to ask you all to join me in thanking our panel for a great discussion.